Okay, we talked about this when we were doing our lesson on Wednesday. Okay, if point A is found on f of x, okay, then, let's define, then f of A would produce a b value. It would produce a y value. Let's say the y value is b. In other words, what point is that representing? A comma b, right? Okay, if you want to, we're talking about the point A comma b. A is the x, b is the y. All right, if b is on g of x, and g of x is previously defined as an inverse function, then we can assume that g of b would produce what for its y value? A, correct. So now we're talking about the point BA. And we talked about that before. All right, that on inverse functions, the relationship between points is the point on one, then the inverse point, switching the x-coordinate and the y-coordinate, would live on the inverse function, on the other function. Okay, so 5, 3 would be on one function, and then 3, 5 would be on the inverse. Okay, we don't change signs. We don't make things negative. We just switch the order. Okay, so keep that in mind. All right. Let's find the derivative. And I'm going to prove to you the derivative of an inverse function. Okay? Can I give it to you? I'm going to give it to you, but we're going to prove it too. It's a little fun. All right. How do we get rid of that? Okay, so let me back up. Let me ask you a different question. How do you get rid of a square root?
Square.
What's square? How do you get rid of a sine? Sine inverse. Okay? How do you get rid of a cube root? Cube. How do you get rid of an f inverse? Correct. All right, very good. All right, so good job. Okay, so we're going to get rid of the f inverse by using an f. All right, so let's apply f to f inverse of x. But what we do to one side, we have to do to the other. So that means I have to apply an f to the g of x function. So what do I have left on the right side of the problem? X by itself. Okay. Now you're very used to having y by itself, but it's just as valid to have x by itself. Okay, finding derivatives are way easier if you can get something alone. And in this case, the easiest thing for me to get alone was the x. Now I'm going to find the derivative. Okay, so algebra first. This is the algebra part. Then we're going to move into the calculus part to find the derivative here. Okay? Yeah, that's one way to write it. I said just wait. Yeah, we're going to. Okay, so how do we take the derivative of f parentheses g parentheses x? Chain rule. What do I take the derivative of first? Okay, so our next thing is to differentiate. And what you do to one side. Okay, so we're going to differentiate both sides. All right, so we start with the outside, f prime. What do we do to the inside? Nothing. Right, we do nothing to the inside. We leave it completely alone. All right, times g prime. And then what do we do to the inside of that? Absolutely nothing. And then we take the derivative of x, dx dx, which will have be v1, yeah. Okay, then we have to take the derivative of the other side, which is dx dx. All right, so we now have f prime of g of x times g prime of x, and then times 1 equals 1. Okay, at the beginning, g of x was by itself. We want to find g prime of x. That's what we're looking for. Do you see g prime of x? Yes. Okay, it's right here, right? How would you get that alone? Divide. Okay, great. So g prime of x by itself is 1 divided by f prime of g of regular x. Okay? Now, one more thing. What letter goes into a g function, whether it's a g or a g prime or whatever? What letter, based on our previous slide that we just did?
B.
B goes in, okay? And then 1 over f prime of g of b. What is g of b, which we just defined on our other thing? 1 over, whoa, okay, that's it. G prime of b is 1 over f prime of a. Which one's the inverse? The g function. Which one's the original function? The f function. Okay, so I want you to hear me. The derivative of an inverse function is 1 over the derivative of the original function. Did you hear that?
Can you say it?
Uh-huh. Which one is this?
The original.
No, which one is g?
Oh.
G is an inverse. The derivative of an inverse is equal to 1 over the derivative of the original, but with what number plugged in?
A.
A. Okay.
Okay, that makes sense.
Yeah, we'll get it here. All right.
Numbers, please.
So, if the original function is continuous, which means no what?
No breaks.
No breaks, no gaps, right? No asymptotes. Okay? If it's differentiable, which means no corners or cusps, and never horizontal. Okay?
So it's not like.
Okay? So never has a horizontal piece to it, even for a fraction, even, instantaneously. Okay? Then we say that the inverse is also differentiable. Okay? So all those things have to be true, and then you find the derivative this way. This is the summary. Okay, the derivative of if you need to write it out in English, you can. The derivative of an inverse at B is equals or equal to the reciprocal of the original derivative at A. It's almost like normal slope. You know how normal slope you find it and then you take the reciprocal, but what else do you do to normal slope?
Flip it.
Okay, you take the reciprocal and you
Negative.
make it opposite.
Oh.
Okay, so this is very similar. We'll find the original derivative. We're gonna flip it, but we're gonna make it opposite. And we don't do that with a negative number. We do that by plugging in the opposite coordinate. Okay, so it's so much the same, but it's a reciprocal, but plug in the opposite coordinate instead. All right, let's practice. All right. Here's the function. It's a cubic function. It's continuous. Okay, we've got it's continuous. It's differentiable. There's no corners. There's no cusps. Okay.
You could do the really nice, we could do power rule with this.
No, -1 does not a power.
No, for the f of x.
Oh, for f of x, yes. For f of x is going to be nice and easy. All right. If g is the inverse, what I want you to be clear about this is you don't have to find the inverse function to be able to figure out its derivative. Did you hear that? You don't have to actually find the inverse function to be able to find its derivative. Because in order to know its derivative, you just have to know the derivative of the original function. Okay, and you need points, so you can plug the opposite point in. Okay? So first, find the original derivative. Okay, the original derivative of the original function is going to be what? It's pretty easy. 3x squared plus 1. Okay, then find the reciprocal of that. Okay, then find the reciprocal, which is 1 over 3x squared plus 1. And then plug in the opposite value. All right, so you got to watch this. It's asking for g prime at 2. The thing is you never actually find the inverse function. You never have to find it. And you never actually plug in 2. What do you plug in instead? What's paired with 2? 1. Okay? Look back. 2 and 1 are together. They're pairs. One of them's the x-coordinate, one of them's the y-coordinate. And we want to make sure that we plug the right one in. And so we're going to plug in 3 times 1 squared plus 1. So the answer is 1/4.
And that's because the 2 represents the b?
Right, because 2 is the b. So this is b and a, right? And for me, I want a and b. And so I want to use the number 1. Yes?
So, like, how exactly do you know which one's B and A?
Because for the g function, it's always that way. Okay, for the f function, it's always f of a equals b. And for an inverse function, it's always g of b equals a. It's always that's how inverses work, because they are inverses of each other. Okay, in other words, what that would tell you is that if f of 4 equals 11, then what can you automatically assume is true? G of 11 must also equal 4. That's how inverses work. They go together. Yeah.
So you always plug in the A.
Always plug in the a. Yep. That's the thing about inverses. And with multiple choices and stuff, it's like you never actually plug in the number 2.
Would they ever like trick you and then put the f of x instead of the g
Of course. They're going to have, if it's a multiple choice, they're going to have like, oh yeah, let's do it. What if they plugged in the number 2 here? Then what would their denominator be? 2 squared times 3 plus 4. So what
13.
1 over 13 is absolutely
No, I mean,
100%
like,
going to be the answer,
In
the
the
option.
question, would they say like, for after the and, would they put the f of x instead of the g of x?
Oh,
So that you would have to.
Oh yeah, you could get the points, and sometimes it comes on a table, and you get your table. Here's your f value. Here's your f values, but then you got to do. Oh, I need g values, right? Okay, well let's try it again. Okay, here's our original function. You just got to keep it straight. Okay, find the inverse derivative at 13. Am I ever actually going to use 13?
No.
No. Okay, but what was I not given?
What 13 was connected to?
What 13 is connected to, so I need to figure that out. Okay, so let's maybe do a little, okay, f of blank equals and g of blank equals. Okay, where does the 13 go?
After the G of blank.
Okay, it's a what value?
It's an A value.
It's a b value.
It's a b value. You had it, you said it the right thing, okay? 13 is the b value, which means where else should 13 appear?
After the F of blank.
It should be here. And so I need to figure out what a is. How algebraically am I supposed to figure out what the a value is?
It can't just.
Okay, algebra, algebra, algebra. Okay, where do I put the 13? Okay, 13 equals 3x to the 5th plus 6x cubed plus 4. Okay, how do we solve that?
Graph.
Okay, if you have a graphing calculator, 100%, you can graph. I'm going to tell you that almost all of these problems are designed to have a very easy, almost AKA obvious number. Like the easiest number you could maybe think of that's not 0 is probably the answer. It is. Does it work?
What?
Does it work? 1, 3 plus 6 plus 4.
Oh my gosh.
Okay? They make it that way. They make it so the algebra is not that hard
I'm supposed to
for you.
figure that out in my head?
They design them so that they are easy.
I'm not going to figure out the 3.
It's usually like a 1 or a -1, or sometimes it's a 0. Okay?
So you just like trial and error?
Almost. I mean, or if you had your calculator, graph it for sure. Okay? Okay? So, x is equal to 1, or in other words, a is equal to 1. All right, so now we know what our values are. Okay, so we've got that. We've got our point. We have the point 113. We also have the point 13.1. One of them is on the f function. The other one is on the g function. All right, but now we want to find the derivative. So what should I find first? Find the original derivative. Find the regular derivative first. Okay, so find f prime first, which is going to be 15 x to the 4th plus 6x squared. No, 18 x squared, thank you, plus 0. Okay, then I find the reciprocal. 1 over all of that. And then what number do I plug in? The 13 or the 1?
1.
Correct. And isn't that's pretty easy math to plug in? 1 over 15 plus 18. 1 over 33. All right, so last one. We're going to do a tangent line. So we need a point and we need a slope. All right, so what we've got started, we've got given part of our point. Our point's going to start with -4, but that's connected, to the f of x function, f inverse function, okay? So that is the value of the point on the inverse function. So just keep that in mind, that this is the f inverse point, which means that the f point is not going to start with -4, it's going to end with -4. So just keep that in mind, which is going to connect us back then to how we're going to find the other value of the point. So we know that -4 is the key, and all we have to work with is the original function f of x. All right, so where am I going to put the -4? -4 equals x to the 5th plus 2x to the 3rd plus x, and then we have -4 at the end. Okay. So it should be, if we've got subtracted 4, -4 at the end, and you've got -4 at the beginning, then the x that will work is going to be 0. So now we know what our corresponding point is that we're working with. All right, so now we've got our point, and now we need to find our slope. So you've got a couple things. You've got your f slope, and then eventually we'll find our f inverse slope. So we want to find our f slope first. Always find the derivative of the original function first. So that's 5x to the 4th plus 6x squared plus 1. And we're going to find the value of that f slope by plugging in the x value of the f point. So we're going to plug in 0. So 5 times 0 to the 4th plus 6 times 0 squared plus 1. So my value is 1. So then by definition, the f inverse slope is the reciprocal of that, which is also 1. So then I can write my tangent line. Just make sure that you use the right point when you write your tangent line. This is supposed to be the tangent line to the inverse. So make sure, since it's to the inverse, you have to use the point that is associated with the inverse. And so we'll have y minus, and that point value would be 0, slope value of 1, x plus